Today's notes, we are just finding the fractional distance of our coordinates. So this is our fractional distant coordinate formula. If you notice, it's the same as midpoint formula from last class, but it's saying you can plug in any k value, right? In the one we were using, it was always 0.5 because we were only going to the midpoint, which would mean middle or halfway. But if they want you to go 70% of the way or 3/4 of the way, you can change out k for how far you're supposed to go. Yes?
If the answer was ever about like inches, would you have to put halfway to 0.6? Because it's like 6.
Why are you asking if you could have a decimal?
Well, like, because isn't 0.6 half of a inch, but a foot is 12 inches?
Yeah, I mean, but that's not what halfway would be. Half of something would be 0.5, right? So if we're cutting it in half, I'm not asking what half of a foot is. I'm just saying we're cutting this segment in half. And to half it would mean to divide by 2 or multiply by 0.5. Okay. So they give us this formula to find the coordinate. Here is fractional distance. It's the exact same as our distance formula. We just put the k in front. Okay? And we already know k is always going to be some fraction or decimal because we had something similar to this back in Unit 1. So here on example 1, it says that Frank must walk at least 35% of the trail before he is allowed to take a break. If the GPS coordinates of the trail he is walking are a start point of -8, -5, and an end point of 5, 12, it says if Frank has walked 8.2 miles so far, is he allowed to stop? So first we need to figure out the distance that he has to go, right, before he's allowed to stop. So that comes from here, right? I'm finding a fraction of the distance, which would mean using this formula, right? Okay, so our distance should be equal to k. What's our k?
0.35.
Right. 35% as a decimal is 0.35. Very good. Times the square root of our x2 minus x1, y2 minus y1. Well, they gave us coordinate points to plug in, right? So this is my start point, or my x1, y1, and this is my end point, or my x2, y2. Okay. So when I have those in my parentheses, x2 minus x1 is going to be what? Very good. Squared. Plus, what's my y2 minus y1? Very good. Okay. So we're going to simplify what we have underneath our radical first. So I got 0.35, and then underneath here I got 5 plus 8, which is 13. And what's 13 squared? 169. Plus, what is 12 plus 5?
17.
17. And what's 17 squared?
289.
289. And what do I get when I add those two together? Good. Okay. Is there a square root of 458? Not a perfect one, right? So what we're going to do is go ahead and type this in our calculator just like this. 0.35 times the square root of 458. And it's going to give us some decimal answer. What do we get?
7.49.
Okay. So my distance is approximately, right, because we did just have to round a little bit, 7.490. We're always going to go 3 decimal places, okay? Miles is our units, right? Okay, so let's say this is the trail he's walking on. Okay, here is his start point, which was at -8, -5, which we said was x1, y1. Here's where he ended up, which is the coordinate point 5, 12 that we said was our x2, y2. Okay? And it said he's gone how many miles so far? Okay, so he obviously hasn't walked the whole thing, or he would have said he was done, right? So he's walked so far, and let's say that this is 8.2 miles that he's walked. Okay. So this is how far he had to go in order to take a break, which would that be further, or has he already passed that point? Right, so somewhere in here would have been the 35%, right? And he had to walk at least that. So, can he stop for water? Yes. So, Frank can stop for water. Since 8.2 miles is further or greater than the 7.490 that he had to go. Okay. Miles. Okay. All right. We got another one. Same idea. But this time they're talking about coordinates. It says Frank decides that he has had enough. When he is done walking 70% of the trail, he calls for help. The park ranger asks him at what coordinates he is so that they can send a jeep to pick him up. Where should Frank tell the rangers he is at? So now we're not just trying to tell how far he's gone. We need to know his exact location, right? They want to know the coordinate, so that means I need to use this coordinate formula up here, okay? All right, so we already have this map kind of drawn out here, right? This was his starting point at the -8, -5. This was his end point over here at 512, right? But this time, we want to know how far he's gone if he is 70% of the way. So that would be pretty far, right? So it looks something like this, but we don't know where this is. This is what we're looking for, right? Where is that spot at 70%? Okay. All right, so we're going to plug that into the coordinate formula, and our coordinate formula says that it's x1. Remember, this is our x1, y1. So our x1 is -8. And then the formula says plus or minus. Remember, we have to determine if we have moved left or right. So I went from -8 to 5, so we moved right. So I'm going to put plus, right? Okay, times k. What's our k this time? 0.7, because we're going 70% of the way, good. Times the absolute value of x2 minus x1. Remember, this is our 2's over here. So what's that going to look like when we plug it in? Good. Okay. And then we have to do the same thing for our y's. So what's our y1? -5, and then I have to determine if I should use plus or minus. So I started at -5, ended up at 12. Plus, 2 and up. All right, times k, which we said was 0.7 times the absolute value of x2 or y2 minus y1, which would be 12 plus 5, right? 'Cause 2 negatives would make a positive. Okay. So now we just need to simplify. So inside the absolute value first, right? So I've got 5 plus 8, which is 13, and then 13 times 0.7. And what is that? And what we get? All right, now we're going to do our y over here. 12 plus 5, which is 17 times 0.7, 11.9. So I should have negative 5 plus 11.9. Okay, and what is negative 8 plus 9.1? 1.1, nice. And negative 5 plus 11.9. Very good. So if he's going to call the park rangers and give them his coordinates, these are the coordinates that he needs to say, right?